So, can you hear me now? Okay, I cannot hear you, which is interesting.
Yes, we can hear it.
Okay, so now I can hear as well. Okay, so that's great. Yeah, so thanks for joining. Uh, we'll start in 2 minutes. Yeah, but yeah, let's see how it will work. Yeah, but maybe I can already start to tell a few words about what we are going to do here, or about some arrangements. Yeah, so. Okay, yeah, my computer is complaining about the quality of the voice here, but you are not, so I hope that it's okay. I plan to upload this recording. I hope that everything will work fine. It's already half an hour, but okay, to YouTube. Yeah. Typically, I rather plan. No, don't do it. Sorry, I have some notifications here. Okay, typically I just make this streaming online on YouTube. But as I wrote to you, I do not have my laptop, yeah, and I have here only some replacement, and I simply wasn't able to install here the software that I wanted. So yeah, so this time it will be on Teams, yeah. I hope that for the next classes I will get back with my standard laptop, so we will be able to work more comfortably. But okay, let's see how it will go. So I think it's time to start it. Yeah. Do you have any questions? Okay. There are some hardware issues, like always. But okay, let's start with sharing. Maybe just sharing the screen. And yeah, okay. So first I will go and see what is the issue, and then we'll get back to the content of this course. Okay, some hardware issues, but not too much that we can do about this. But okay. So welcome everyone again for our course on computational methods in mechanics. Let's see how it will develop. Yeah, we have few things to discuss at the start, but yeah, without maybe further waiting, let's go. Yeah. So firstly about organizational matters, then very briefly about programming. Why Matlab? We could, yeah, because it's popular simply. And then we'll go to most likely first Matlab programs and more basic concepts, yeah, in the programming. But let's see how do you feel about this? Yeah. So organizational matters. Yeah. So first of all, we want to cover the MATLAB basics, like of course linear algebra, yeah, because MATLAB is famous from being able, at least when we talk about MATLAB programming language, yeah, to deal very well with matrix calculus, yeah. So linear algebra is at the core of the development of this program, yeah. Then we'll talk about some possibly some useful numerical algorithms, yeah, that we will use later on, in our development of the simulation software. Yeah, so stuff like numerical integration, yeah, to understand the concept, be able to code it, and so on and so. Then solving nonlinear equations. This is very useful for when we will go from for the simulation software that deals with kinematics. We'll also talk a little about symbolic computing. Yeah. Also, hopefully, we'll be able to cover some things that are connected with good programming practices like testing, and maybe also with version control systems. And later on, we'll delve into, because we are in the course of computational methods, so we are already about computational methods in Matlab, but also about mechanical systems, yeah. So in mechanics, so hopefully we'll be able to solve the systems like here. Yeah? Here you can see typical this potato-like diagram, yeah. But typically, we have more concrete examples like those slider crank forward mechanisms and many others, particularly planar, and because planar are typically much easier than spatial, that are well pretty meaningful in the context of mechanical engineering applications. Okay. Kinematics, dynamics, hopefully, so we'll deal with solving also differential equations. Yeah, hopefully we'll be able to write general solver, and if we'll rush a little and time allows, maybe we could even get a little into maybe machine learning, because it's quite interesting, and I believe that also Matlab is involving and investing in this sector quite a lot. But let's see. So, any questions to what is about the course content? Any suggestions? So I have one question about the course content. Yeah. So let's get back here. Yeah. So is there anyone here online or offline that is not well familiar with MATLAB programming? Okay, and but you are not familiar with MATLAB programming, or you are not familiar with programming? Okay, so do you know some other programming? Python programming? Okay, okay. But so is there here anyone that concepts like variables, conditionals, functions is kind of foreign for him or her? Or all of you knows those concepts? Okay, so there is a chance that today we'll go pretty rapidly through those topics. Yeah, we'll just stop maybe to get some quick hands-on exercises, yeah, to see how it works. So that's good to know. Online also, I haven't heard or seen any complaints, so let's keep it going. Okay, about the grades, yeah. So traditionally, this course I was using those two elements, yeah. So some homeworks, yeah. So typically every second or third week you have some homework, yeah, that is connected with the course contents. Today we have initial classes, yeah. Nothing will be assigned for you, but hopefully already on the next week, and projects or some final project. And yeah, this was done like that, yeah. Hello. So how do you like it? Yeah, our particular. Okay, so I hope that you don't want me to remove any of those, yeah, because then we have to refer to some exams, and I would prefer not to make exam. Of course, if you really would love to have one, and then we can discuss about this. But I was also thinking if we should include something extra. Yeah, I know that, like for example, on the course Aki or maybe others who have something like in-class quizzes or stuff like that. Yeah, I don't know if you like it. And okay, okay, so I'll think about this. Yeah, so maybe for the next time I will do some experiment and see how it works. Yeah, if we totally fail, yeah, then we can just forget about this. Yeah, but maybe it's good to think about trying it. Yeah, so I will try to prepare something when we'll get to more concrete material. Like most likely it will be this numerical integration to go with it. Yeah, and then we'll see how it will work for us and how it will work for this course. Yeah. Okay, perfect. maybe I will be able to somehow combine it with those hands-on exercises. Yeah, because when you have some hands-on, yeah, and then if there's maybe some simple task to solve, yeah, then you have to still write some program to solve it. Yeah, and yeah, this could work. Of course, you can use some large language models to help you with those tasks, I suppose, but yeah, who knows how it will work. Yeah. Okay. So if there are no further questions or suggestions, yeah, let's get to why programming Matlab. Yeah. Okay. So why learn programming? I suppose that it's not super needed for you, especially that you are already into programming, as I understand all of you in one way or another. Maybe it's not Matlab, but then this is just technical detail about learning just how the program works and how to organize it and run it. And Matlab, especially for starters, I believe is pretty forgiving and easy to learn. Okay, so of course, yeah, the main thing about programming is the first one that that programming require you to write the things that you want to do in programming language pretty precise. Yeah, if you just yeah, so if you have some experience, you for sure know that even if you make some slight mistake, yeah, then it result in program that it's not working or is producing incorrect results. Yeah. Yeah, and the main goal for us will be to create solutions for our problems. Yeah, so we will have some real world problems. Yeah, like the designing task. Yeah, possibly. Yeah, hidden behind those mechanical engineering mechanism, and we'll be able to. We want to analyze it and see if, for example, if they meet some design requirements. Yeah. Okay. Perfect. Uh, this is now maybe languages and abstraction levels, yeah, that typically we are currently working only with high-level languages, yeah, because as you probably know, the computer speaks in binary code, yeah, currently, yeah, so they speaks in the language of ones and zeros, yeah, so whatever we do here for computer is just a bunch of those ones as zeros, yeah. It's not here. Okay, like it's here. And of course, then we have assembly language that, in some, I suppose, 50 years ago was a very nice way that instead of writing those zeros in one, you can have those potentially high-level comments. Yeah. What is important to note here that first two levels, yeah, are of course machine-oriented, yeah, and they depend heavily on the just what hardware do you have, yeah. So then you have to bother even with the stuff if you have, like Intel processor or some ARM processor or whatever, yeah. While for high-level languages, uh, you just write the code, typically in the plain text, yeah, and then if certain architecture supports it, it just works, yeah. And so the first one are again hardware-oriented, machine-oriented, yeah, and the next one are rather oriented towards solving particular problems without bothering with what kind of the hardware do you have in the first place, yeah. And so it also came with this idea that programs are written mostly for humans. Yeah. So we are writing program for other programs, but we'll talk about this maybe later. Yeah. And yeah. And here is Fortran punch card. So yeah, now we are okay. Yeah. In the very old days, yeah, but it's not even my days. Yeah, I just know people that were using this kind of punch cards to write programs in them. Okay, why Matlab? So it's very popular in engineering. Yeah, so this is, I suppose, one of the main reasons. Yeah, it's also popular in just in science economy. Yeah, here you as a student have access to just to Matlab, so it's very convenient. Yeah. So it's very nice language for solving engineering problems. Yeah, it has very good documentation. which is very nice, yeah, and it's on hand. It has a lot of educational materials, yeah. Now it's available even online. That's why we can have this course today, yeah, because I wasn't able to install Matlab on my computer, but I was just able to sign for Matlab online, yeah, and it just works, yeah. It's really nice for rapid development, yeah, because it's interpreted similar like Python, but I suppose that even simpler, yeah. You just don't have to bother with many of the things that you have to bother with some languages like C or like that, like having those declaring variables, yeah, and so and so. Yeah. And I believe my experience with Matlab is that it's done in the way to be robust, yeah, which is just good for engineering practices. It has very nice graphic support, yeah. So just when we get something done, yeah, some numbers, then we can visualize them quite nicely. Yeah, so those are advantages, yeah. So I think that there are quite strong points. Of course, there is many reasons why not to use Matlab, yeah. Like, firstly, it's just product of MathWorks, yeah. So if you want to use it anyhow outside academia, you need a commercial license, and sometimes it can be just prohibitive, yeah. Typically, it's not super fast. Yeah, it's getting better, of course. Yeah, also hardware is getting better. So for our small scale things, it's not so important. For us, it's far more important to be effective, to write the code fast, yeah, and to prototype and develop ideas. But if we really would have some larger scale computations, this can be prohibitive, yeah, because standard MATLAB program without tuning can be, let's say, even 100 times slower than the comparable code in like C, Fortran, or Julia. Language can be limiting. Well, yeah, because it is mostly about writing code in the standard procedural way. Yeah, it has some classes, but it's also not very modern. Yeah, so but it also means that very old MATLAB program still works. Yeah, so they are not really modernizing the language very strongly. It might not be the best for the large projects, but still some large projects exist. Yeah. Yeah, not the best source code editor, but it's still getting better. Yeah. So, but on the other hand, you just run MATLAB and everything is there for you to work. Some final notes. So MATLAB has, of course, many alternatives. Yeah, one of those is GNU Octave. Have you ever heard about GNU Octave? Okay, so it's in very short, open source implementation of the MATLAB language. Yeah, so it's theirs. It works. It's even more limited and slower than MATLAB. And we have access to MATLAB, so we'll use MATLAB, but there is this kind of the alternative. Yeah, if you cannot get, for example, the MATLAB license, there are of course many other solution. Yeah, I think that especially scientific Python gets very popular in the last years, also because of the machine learning and also because it's very mature. But okay, yeah. Parts of those courses, especially that initial part, yeah, is based on the book that it's written here. Yeah, it's, as you can see, it's already like 8 years old, but on the other hand, MATLAB hasn't changed within those 8 years in its programming basics a bit. Yeah, so it's still completely valid. After this course, I'll put those slides on the Moodle. Yeah, so I will also put this recording on the Moodle. I will also put the link to this book. Yeah, there. Yeah, so that you can Google it easily, but it will avail to you out there. Okay. Any questions? Programming. Yeah. So you should know that, but just to be in line, let's go through it. Yeah. So we are typically implementing the programs, yeah, in certain programming language. So Then we are executing the program. In Matlab, it typically works, I believe, with F5. You can run the program and then interpreter goes through it. Yeah. The program is typically written by using some kind of the algorithm. Yeah, we'll deal with algorithm development for the task that you are trying to solve. Yeah, like this integration, like maybe solving differential equations. Yeah, and then implementing them. Of course, there are bugs. It seems that we have bugs because of some historical reasons. If you will go into bug on Wikipedia, I think that you can find this photo. Yeah, so this was the first bug, and simply in the very old days and very old computers that rely not on transistor but some relays. Yeah, there was actually a bug. Yeah, in the hardware. So this is the name. And of course, if you write any kind of the program that is longer than few lines, the chance that you have some bugs in this is almost certain, yeah, almost like 100%. Then, of course, we have to practice the art of debugging, yeah. Do you know how to debug codes in Matlab? Hmm? A little, yeah, but you know how to put the traps, yeah. In Python, I believe, Yeah, you put the traps, yeah, those stoppers, then you run the program that you check it in Matlab. So yeah, you will learn it. In Matlab, it's very, very convenient. So this is another advantage of the Matlab that debugging, profiling, and other stuff are very easy to do. And then at the end, we'll deal with simulating, yeah. So trying to mimic real-world programs, yeah. Fortunately, mechanical systems are pretty well behaving. Yeah, of course there are still phenomena like some deformations or some strange stuff, and especially in one of the phenomena that it's the most troublesome is friction. Yeah, because it's pretty complicated. But if we have limited frictions, all those mechanical components are behaving very, very nicely. So even our relatively straightforward simulation software should be able to simulate the reality very, very well. Okay. First program, yeah. So starts with extreme basic. So let's just get maybe into the Matlab, yeah. So again, I wasn't able to get Matlab done on this laptop, yeah, but I hope that you also should have access, yeah, to Matlab online, yeah. Okay, you don't have access to computer, so you don't have access to anything, yeah. Sorry about that, but well, yeah. After solving this, you can get back maybe to this recording. So, by the way, I have seen that there are also courses on Matlab online. Yeah, so especially if you have like your knowledge about Matlab, especially Matlab fundamentals, is slow, and you want to improve them, beyond this course. Like here, you have online training in Matlab fundamentals. Yeah, that introduce all the essential parts like Matlab desktop, basic manipulation of arrays, data, and many other things. Yeah, we'll cover it, but very, very quickly. Yeah, so it's so it's there for you. Okay, but we'll get to Matlab. Yeah, fortunately, Matlab online. Okay, it starts as long as typical Matlab, so no new things here. But when it already starts, it looks pretty similar to standard basic Matlab session. Yeah, so we have this typical Matlab interface with command window in the center. Yeah, we have here the workspace where our variables are visible. Yeah, we can manage the files, and we have this standard ribbon, yeah, when we can deal with just editor, Matlab environment, and all this stuff. So are most of you familiar with Matlab interface? Perfect. So, yeah, we won't get super fancy here. Yeah, the most thing that we will need is to create new script. Yeah, how to write the script. and then how to run it and how to see results. And then we'll deal with the plotting, but mostly everything through either command line window or just directly by programming. So always we can write a new script, yeah, and then we are just ready for programming, yeah. So we can write think that I should try to increase the size of the font, yeah, because can you see what is written here? From the back? Can you see? Okay, wow, yeah. Good young eyes, yeah, so can see everything, so that's perfect. Yeah, so still, as I can see, Matlab doesn't have any kind of spell checking. I don't understand why they don't have spell checking for the comments here, because you shouldn't make spelling error in the comments, and especially when the English is not your native language. But okay, it is what it is. Yeah. So if we want to write this relatively simple program, yeah, to model, here we have already, mathematical model for this. Yeah. So yeah, any questions to this model? I think that you cover it in some first grades of physics. Yeah. So nothing new here. We just want to, use at the moment Matlab as some kind of the calculator, yeah, and try to solve it, yeah. So assuming that we know the initial velocity v0 at some time, and of course we have knowledge about what is the acceleration of the gravity in our local conditions, yeah, and to have some vertical position of the body. So we have to write all of this. So let's say that initial velocity will be 1.5. And then we, of course, have G equal to, for example, 9.81. And then we wonder what happens after, for example, 3 seconds here. Right, just equation it's stated there. And then hopefully it works. Okay, so firstly, it asks us, of course, to save the file. Let's call it ball. Okay, and it works. Yeah. So in our conditions, it drops quite well below the level surface, because it goes to up to minus 40 meters. Yeah, I suppose that we should have higher velocity if you want to have more meaningful throw of the ball. But okay. But we are not here to become the expert of throwing the ball up in the air. Yeah. By the way, assuming that there is no air, as you can see in the model. But here we have the first MATLAB program, yeah, and we can already see quite a few of its characteristics. Yeah. So first of all, yeah, the program, and in most programming languages, program is just written as just plain text. Yeah, that must be interpreted by some interpreter or compiler. Yeah, in this type is interpreter. Yeah. So program should be written, in the way that is, of course, mostly understandable to a programmer. Yeah. So written in the way that it's understandable to humans. Yeah. So it means that it has some useful names everywhere. Yeah. And if needed, it's accompanied with programmer comments. In Matlab, another characteristic, so those programs or scripts, yeah, because there are two types of entities in Matlab, we'll get into it, are stored in so-called M files, yeah, that one, bol.am, yeah. Of course, you can open them in Matlab or in any standard text editor, yeah, to see their content. And there are quite few assumptions already in this very small program. Yeah? So first of all, that everything that appears after this percentage sign is totally ignored by the interpreter. Yeah. So if you put percentage sign somewhere, yeah, maybe except of the text of the literals, text strings, yeah, then everything that appears after this percentage sign is just ignored. Yeah. So you can write whatever you want there. Yeah. It won't be the interpreter won't try to execute this program. Yeah. Next, you can already see that interpreter in general ignores all blank lines, blank signals. Yeah. So new line characters are ignored, spaces are ignored, and so and so. Yeah. As you can see, also some of those lines, I put the semicolon sign in there, and here I didn't put it. Yeah. Also, the editor shows here some warning. Yeah, it's good to know what are the warnings. Good to check them and see if they are meaningful or not, because they can have some useful hints. And the program works like that. That in general, here we have a bunch of assignment statements. Yeah, so we're creating variables. So it means that we create just handles for the memory with certain values. Yeah. All those values already have some default type. For Matlab, default type is double. Yeah, so all those numbers are double, which you can see here in the workspace. Also, all those after execution of this program, all those variables end up in the workspace. Like here, they have those values that we put here. And the very last statement for y was printed in the command window. Hopefully, a lot of assumptions. Yeah, but it's understandable. Yeah, yeah. Power of the natural language models is awesome. But okay, any questions to this program? Everything is clear, why it works the way it works. Do you know what is the meaning of semicolon? Sorry. What is the meaning of semicolon? So it's understandable. That it just prevents from displaying the stuff. Okay. Okay, yeah. Okay, so perfect, yeah. So this is how the basic Matlab works, yeah. Yeah, so we were able to create the script file, run the program, I hit F5, yeah, and it runs. Of course, aside of this, here we have those run buttons, yeah. Yeah, so we already, I think, discussed about those points, that computer program is plain text, that we have M files that are interpreted read by Matlab, yeah, interpreted, yeah, and of course they are read from just in our, I think, natural way of reading, so top to bottom, yeah, from top to bottom and from left to right. Yeah, it always works like that. Yeah, you should understand all the instructions, the program. Yeah, just to avoid some kind of, something that really surprises you. Yeah. Yeah, and you will get the same effect by running all those commands in the workspace. This is clear? Yeah, that that it would be the same if we just put here all that stuff like 50 is 1.5, yeah, t equal to 3, g equal to 9.81, yeah. By the way, I have error here. Yeah, and then yeah, exactly the same result, work exactly the same. In the workplace, we have also exactly the same set of variables. Good. Okay. This also, I think that we have discussed about this, so I will just leave it for the slide. So we have comments, and it's good to have some comments that shows what is done in the code, that it's not super trivial. Yeah. But typically it's not a good practice to have too many comments, because that they can distract you. And also comments require to take care about them, because it's very, very typical that you write some first version of the program, put there the comments, then you change the program, but you forgot to change the comments. So sometimes it's better not to have even those comments, if they are not maintained, because they can just cause confusion later. And of course, again, program code is written for humans. I have 3 collaborators that insist that program is written for the computers, and it was difficult because then we have program that you cannot really read well, and it takes a whole lot of time. But this is the case. Okay, so I hope everything is clear. Program works, here there were just another number, so something else was printed there, but everything works as expected. Okay, error messages. So here, if you have Matlab, I think that it would be great if you can go through those steps, and check what is the effect of those for your program. This is one. If you are pretty experienced with Matlab, it's not maybe not big thing, because then you have seen all those possible errors already, But I think this is pretty important practice, because understanding the errors and what they mean, it's just useful, because then when error appears, you are able to figure out what is happening and where it is happening much nicer, because not always errors indicate directly what is the issue there. Do you want to try it by your own, or we should just do it? Yeah, on your Matlab. Because, for example, what you would expect to see for the error if you put word hello. It just writes like that. Okay, let's check. Yeah, so because what is hello here? What should it be? Yes, you can see it works. Yeah, but hello works. It's ask you to write hello, so yeah. Okay, so yeah, as you can see, language is evolving, yeah, because in all the earlier version of those courses, this was error, yeah. So yeah, so I have to change the slides. I can see even, you know, to make it work the way it should, yeah. So as I tell that, you know, using the book that is 8 years old is not maybe a big thing, but sometimes, you know, like in these cases, it seems okay. Let's try hello to. Yeah. Okay, with hello to it works. I mean, it shows the error, yeah? But of course, in general, you're right, yeah. Whatever you write here, yeah, in this kind of the text, yeah, that looks like a variable, yeah, uh, it is expected to have it as a variable. So it means that in this context, we are in a global context, it expects to find it in the workspace, yeah, or somewhere in the search path. But because it didn't find it, so it shows there that unrecognized function or variable hello to. Yeah.
Put a semicolon back at that.
If I put semicolon here, I think, yeah, it shouldn't change. By the way, it's written again, you know, about precision in programming, that it's function or variable, yeah. So it means that, of course, it can be variable, yeah. So the thing that we would expect to see in the workspace, yeah. So if we would write here hello to equal to 0 or whatever, then it would work, no problems, yeah. But also a function, yeah. So as you can see, not like in many other programming languages, I don't remember how it's Python. Can you have run function without parentheses in Python? Do you remember? If you can write function without parentheses in Python. Yeah, I don't remember. I'm pretty sure there are many languages that doesn't allow it. Yeah, but you always have to check because those are some of those very small details. Yeah, like can you have function without arguments, without providing parentheses or not? Yeah, because it's not obvious. Yeah. Okay. Do you know what I'm referring to? Yeah. So for example, if you have this hello, yeah, it's and writing hello, those parentheses should be the same. Yeah. So typically when you have function, yeah, at least I'm used to that when you have function, then you call it, yeah, and when you call it, you have parentheses, like here, yeah. But in Matlab, if you have function that works without any variables, yeah, you can just write it like there, yeah. So you can skip parentheses, and it still works without, you know. So the code is equivalent. And I suppose that if you write hello to with parentheses, I would expect that it say that it's unknown function and not unknown variable, but who knows? No, it says the same. But okay, it is what it is. Uh, remove sign. Okay, so what error comment you are expecting here? Yeah, exactly the same. Because then we just end up one statement here. By the way, this kind that ends with semicolon is just statement. Yeah, that must be valid. And then we would expect to have here, can it be function as well? Is it run as a function? Just try to run as a function, by the way. It's another stuff of the Matlab, because again, when you get into programming, and there are some obscure ways, yeah, so the programs we are writing typically are nicely written, but you can get the same in many different ways, yeah, because I suppose it treats it as first argument, string in, because because you know that we'll get to it, yeah, because comment sometimes works. For example, we can write save and then provide the names of variables, for example, or stuff like that, yeah. But okay. Exactly the same. I recognize function or variable and velocity. There is, I don't. Okay. Because I think that there's int. Oh, okay. I would have to check it. But okay. Remove the equal sign in the assignment to V0. Let's see. Okay, I recognize function variable V0, despite it's here. Yeah. So we have V0 declared. So I would say
But
that
only bad because it's previous work. You do need a workspace now, but
no. It's not the case. Yeah. Because if you would write here just V0, it would recognize it. That's why it's that one?
Yeah.
No. Okay, if we are on this topic, of course, there exists separation of the workspaces, but this is just a script. Yeah, so to create this kind of separate space, you have to separate it.
that be zero was the previous workspace.
Yeah. Yeah.
It doesn't run it again.
So I'm not sure what they are expecting me to do here. If I clear it,
But it's like the reason
yeah, but the code doesn't work in this way. I'm not sure if I understand,
said like it's going to be zero, but there is no other.
yeah. However, it's still misleading because it's right, I recognize function or variable. Yeah, so it shows that it seems that it throws this error despite there is a variable v0, yeah, but it throws it because we try to use it as a function. Yeah, because I'm pretty sure that this type of the call this type of the statement try to call v0 function with string 1.5 because yeah, that's why sign of 1 doesn't work because it's a string. Okay. Okay. This is interesting. I don't remember what it causes. Any guesses? Yeah, but Python is much older than Matlab, I believe. Yeah. So that's why this is the way you bring to the power in Python, but it's not the way you bring to the power in Matlab. Yeah? To bring to the power, have this dash symbol. Yeah. Yeah. Invalid use of operator because you stack two multiplications together, which is not allowed in Matlab. But yeah, it's valid in Python. And of course, this is interesting. Yeah, if you change the calculation y to y equal to v0t. what will happen?
Just calculate.
Yeah. So is this program valid? No. No, it's not, of course. Because this is the program to simulate the ball thrown up in the air. Yeah, it calculates something, but it doesn't work. Yeah, so of course it works technically, yeah, because it calculates and doesn't throw errors, but it gives you results that it's totally irrelevant. Yeah. So this is the worst type of the error, yeah, that everything works, but but then BT collapses, yeah, because you get the results that are just totally meaningless. Yeah. What was your comment? Yeah. Yeah. So not up. Write x on the line just above where x is calculated. But okay, yeah, if you write x here, yeah, it will be the same, yeah, most likely. Exactly, unrecognized function or variable because there is no x. Okay. So those are some of the errors. Most of them were unrecognized function or variable, despite there were some variables. So again, you have to just get used to the errors and how they work. And that's all. Any questions? Okay. Maybe short break and you can write this kind of the program. Yeah. To MATLAB. Could you repeat? If we what? Y is a function? No, it's not a function. It's statement. It's variable. And you mean that we don't need semicolon? No, we don't need. No. It's okay. So there are two reasons to use semicolon. Yeah, at least. Yeah. So you're right that one thing is that if you use semicolon, we can put multiple statements in one line. Yeah. So like if we have nothing in the workspace, we can write v0 equal to this 1.5. Yeah, and t equal to 3 in one line. Yeah. Okay. But the reason I didn't put here semicolon, by the way, here you have error and you can read it. Add a semicolon after the statement to hide the output in a script. Oh, so I wonder how it now works in a function. Yeah, so language is evolving. But okay. So the difference is that if I put here semicolon, yeah, and I run this script, so just I will clear it, yeah. And as Matlab programmer, so this is one of those differences with respect to Python, that it shows no output, yeah. So it puts all those variables here in the workspace, but no output, yeah. But if you remove the semicolon, yeah, it always, yeah, without explicitly writing to display, because of course, to avoid this error, yeah, in the code, you can always write something like that, yeah, so that it calculates and then displays it. It's similar. Okay. Yeah, sure. So this is how it works. Okay. So can you write this kind of simple program? It should take you just like a minute. So write a simple, it's practice script that computes the volume of volume V of a cube with side L. Yeah, just 3 lines of coding.
It's not that serious, but. About these people that are program. I didn't do it, that's all, but that's a lot. Because I consider this. And function. I didn't like the. I don't like that, that's always has. Okay. And the sense. You proceed.
Okay, so no issues. Good. Okay, so and of course, as we discussed, many things that came to the use of Matlab, it's about its wide library functions. Yeah. So we'll learn about the functions a little more. So do you know how to use library functions in Matlab? I suppose that you know. Yeah. So what is the name of the function that can help us with solving this problem? Again, what is the angle of the ball? Yeah, with distance x and y. Here you have equation. Yeah, so standard, of course. Then here we write a very simple algorithm. that we have tan of theta equal to y over x. So if we want to get the angle, this is the equation, yeah? So what is the name of the function that we are using to solve this? Yeah. Yeah. How to find it if you don't know? Yeah. Exactly. Yeah, you have many ways to do this. Yeah. So good that you know. And yeah. And you're right that in Matlab is atan. Yeah. Of course, it can have different name possibly, but in most cases, arcus of tangents is or inverse or tangent is atan. Yeah. So here's atan. And that's all. Yeah. And then if we want to use it, yeah, we write that, for example, we have y equal to whatever 10, x equal to 5, and then we can solve it quickly, y over x. Yeah.
Where I can find the list of all the files and my. And well,
Or just help. Yeah. But I think that it's pretty difficult to, if you want to find all the functions or go through it, because there are, I would suppose, hundreds to thousands of functions, and depending on the library. So it's rather goes another way around, that you try to solve some problem and then you try to search for it. Yeah, like here. And just search for inverse of tangent. Yeah. Basic MATLAB, and then you have atan2 and atan. Yeah, depending on the use. Yeah. Do you know atan2 function, by the way? What is the difference? Exactly, it's written. Yeah. Okay, because tangent is periodic. Yeah. So this can give you just values. It should be written here, yeah, from from minus pi2 to pi2, yeah. And the reason is that depending if you have angles that are positive, negative, yeah. So that's why if you want to get the full coverage of minus pi to pi, yeah, you need to provide information about the sign, yeah, of some variables, yeah. So because for atan, because it like here, yeah, you have y over x. So if both are positive or both are negative, the number is the same, but the value is different, of course, yeah, because if all are positive, it's in this it's in upper right, quarter. Y both are negative, it's the lower left, yeah. And difference is that this atan2, and the name is because it accepts two arguments, because it accepts those arguments separately, it can make these adjustments. So for atan2, you can provide just them separately, and because they are in this range, you get the same value. But if you provide here them with both minuses, yeah, it goes into another quarter. Yeah. Okay, so I suppose that it also answers the question about how to find them. Yeah, exactly. Nothing so good. Yeah. Second program, function parameter, it's clear. Yeah. Here, at least the original program that is written here also converts from radians to angles, because I don't know how about you, but for me it's far easier to think about angles than radians. But yeah, not okay. Visualization and plotting. Okay, known concepts. Okay, you might not know them directly. Okay, I suppose with Python is similar. Just the names are different. Yeah. So just to visualize. So let's just visualize this program. Yeah. So have a new script. Let's copy this. Let's name it. Okay. So if you want to visualize the trajectory of this ball for time from 0 to, for example, 1 second, yeah, how we should do this in Matlab?
Array.
Yeah, of course. Array. So how to modify this program?
Press T and modify.
Yeah. And how it should be modified? Yeah, this is one of the possibilities. Yeah. Perfect. Linspace. Yeah. Linspace takes 3 arguments, and here we have x1, so it's initial, it's start, then it's end, and then number of the points. Let's say 1001. Yeah. So if you run this program, will it work? No, I doubt. But let's try. No, it's not working. Yeah. So let's clear the workspace, yeah, just in case, and run it again. So we have G as always, yeah, we have V0, yeah, and we have T, and you know it's just array of 1,000 values as we expected here, so it goes from 0 to 1. So why it doesn't work? It's written here in the error message, yeah. So it doesn't work because Matlab has 2 types of operators, yeah. One are and those are just basic operators that works properly with scalars and matrices, yeah. And there is also the second one of the types of arguments with dot, yeah, that works like it's written here, element wise, yeah. So here, to make it work, we should put here just a dot, yeah, and then it will work, yeah. Then we get also why date is a vector, yeah. Is it clear for everyone why one works, another doesn't? Not for you? I think that I have this on a slide, so let's see if it's here. Yeah, yeah, it's here. Yeah. Uh, so as written here, this exponent to the power 2 with dot works element wise. Yeah. So again here, yeah, if you put t to the power of 2 without this dot, it means t times t. And the second, if you put dot here, it means t dot power or multiplication t. Is it clear what is the difference? Okay, maybe I will show it in another example. Yeah, so let's say we don't use x here. So if x is equal to 2, yeah. So then it's a scalar, but it's good to remember that Matlab is, of course, array language. Yeah, so it's scalar. It means that it's array 1 times 1. Yeah. So then if we write x times x, it's a proper operation because array has correct size. Yeah. So that's why it works. Yeah. So that's why it works. So x times x gives you 4. If you provide x, it's no difference because it's just one scalar. Yeah. So for the scalar, both are equivalent. Yeah. It makes a difference when we start to have arrays. Yeah. So by the way, so if you don't know, this is the way how to declare arrays. Yeah. So we have array 4, 0, 0, 2, let's say. Yeah. So this is a square array. Yeah. So if we have x times x, it means that this is standard multiplication. So in the language of the Matlab, it's matrix multiplications. Yeah. So it performs multiplication, yeah, just of the matrix. Yeah. While when we have that it makes element-wise multiplication. Here is the same because this the die of the matrix, yeah. So let's put here something else. Matrix multiplication, element-wise multiplication. Understood? Do you know matrix calculus? Yes, so the first one is just standard matrix multiplication, element-wise. So it takes elements that are relevant, yeah. So it takes element-wise, yeah. So element first with element first, yeah. So that's why it's 4 by 4, so it's 16, and then it's -1 times -1, so it's 1. Make sense? Yeah. So of course it's okay, so this is important to remember, not to introduce this kind of errors, especially when you work with this kind of, for example, square matrices, because as you can see, for square matrices, both works, and it gives totally different results. For scalars, it doesn't matter. For square matrices, it matters, yeah, or the... But if we have just a vector, then of course, x times x doesn't work because sizes are incorrect. Yeah. So to make it work, you have to make the transposition of one of the elements. Yeah. In practice, this is also not transposition. Yeah. Because correct transposition is also with that. If we get into real details. Yeah. Do you know what is the difference between this with that and without that? And so this transposes exactly, and this area one, what does this do? What is the meaning of this? No, it's not inverse. It's adjunct. When adjunct makes a difference in complex numbers. Yeah. So do you want to see it? So let's say that it's 1 minus I, and the second is 1 plus 2j. Yeah. So here, by the way, so I already introduced here complex numbers. Yeah. So we get like a storm nice. So complex numbers, because of the context in electrical engineering and in different branches of engineering, is called I or J, because I is typically current, whatever. Yeah. So I and J are by default variables. That means imaginary unit. Yeah. So that's why we have here complex numbers. Yeah. So if you put X, as you see, it's adjunct. So it means that it, of course, transposes the size, but it also changes the sign for the imaginary part. So for real numbers, it doesn't matter if you put this dot or not. For complex numbers, it matters. Yeah, because then if we put x dot this apostrophe, then we have just transpose. Okay. Make sense? Any questions? Perfect. Okay, but we were writing some simple program and we get a little aside of it. But I hope that it clarifies for you as well. Why do we need this dot? Yeah, what is the difference between operators with that and without that? And that those are element-wise, and why, for especially for vectors, only one of those works. Yeah, because again, without this dot, it would be t times t, which it would expect to have matrix multiplication, and because this is of the it's not square. Yeah, it cannot work. Yeah. And why here, why we might have a dot, we don't need it, because when this is a vector, of course, the vector times scalar, it's obvious, it's also vector, yeah? Obvious like obvious, yeah, but in MATLAB, it implicitly says that with the scalar, it's always element-wise operation, yeah? So that's why it works, like here also, it's scalar, and then minus between two vectors, what you can do with two vectors, yeah? It's always element-wise. And now we can plot it, yeah? And to plot it in MATLAB, you just plot it. Yeah, so plotting in MATLAB is pretty straightforward. Yeah, of course, those plots are maybe not the most beautiful one. Yeah, but then we can make it much nicer. Yeah, of course, we can write. So what we have at x? It's time. Yeah, thanks. Time in second. And in y is what the displacement. Yeah. In our case, it's in meters. Yeah. And then, of course, we can change the title, we can change the style of those plots and others. Yeah. Any questions? No, works. Oh, this is nice. Yeah. Yeah. And some plot and some label. Yeah. Here I put the longer ones. Okay, this is also very basic, so I don't think that, we will bother with making this. You seems to know MATLAB much better than some of the previous groups. Okay, command window, the same. Yeah. Again, if we put something in the script and then we put the same or the same commands in the same order in command window, the result is the same. And we all, in both cases, we work in the global context. Oh yeah, just here that there is this ans variable. Yeah. So if you put here something but without assigning, it creates this ans variable to store the last value. Sometimes it's useful, yeah, especially in the command window. Our arithmetic operator precedence. Do you know this concept? Do you know how it works in MATLAB? It works like it's written here. For the basic operators, of course, it's important because there is a lot of operators. Here we have just those basic arithmetic operators. But for example, there is operators like this vertical bar, which is typically some kind of the or some kind of the shift. And then it's a question, what is precedence of it? Yeah. Of those the operators that we do not use very often, and then it varies from language to language. Yeah, but for standard arithmetic operators, it works the way we expect it to work. Yeah. So first, of course, it's bringing to the power. Then our multiplication operators. There are summation operators, and then at the end we have assignment. Yeah. So why this is important? Of course, why the interpreter works as we described from top to bottom and from left to right. It also, has to be aware of those operators' precedence. Yeah. So in the statement, while maybe the interpreter would go not naively from left to right, of course it doesn't. Yeah. First of all, it will do this operator, and it will make this multiplication, store it somewhere, makes another multiplication, store it somewhere, then it can sum the numbers, then makes another division. Yeah, then this operation, and at the end, it has to go back with everything and make this summation assignment. But okay. And of course, we can introduce some subtle errors with it. Yeah. Like, what is the result of this? So if we put here is equal to 4, yeah. And then we would like to calculate something like that, yeah. Yeah. So what is the result of this expression? Yeah, of course. Is it correct? No, of course not. Yeah, because we were expecting to get 1/5. Yeah. So we're expecting something like that. Yeah. And now we get to the topic of the rounding errors as well. Yeah. So of course, Matlab shows us what we want to see, like here. Yeah. But there is this nice function fprintf that shows our nicely formatted string, yeah, and then we can get the full extent of the number, like here, yeah. Yeah. So a few questions. Yeah. Do you know what I have done, and is it correct or not? Because we just put here in practice 1/5. Yeah. So, or 0.2. I can even write it 0.2. Yeah. And when I print it with 17 digits, yeah. So here I write a function. So fprintf, it means print the file, but when it's not file, it prints here. It's a little confusing, but it came from C. Yeah. So then I return that formatted in the way that it's written as a floating point number. So it's printed as floating point number and shows me 17 digits after the dot. So it prints here 17 digits after the dot, and we print 0.2. Yeah. And here we have this one at the end. So is it correct or is it not? So why we have this one at the end? And okay, so do you know this concept or not? Why this is one and why it's perfectly correct? Yeah, of course, you are right. Yeah, but yeah. So here our colleagues start talking about how many bits are used to store the numbers, and this is correct. Yeah, and that's why it matters that we have here 17. Yeah. Let's see what I have on the slides. Yeah, if it's here. Yeah. So yeah. So it points down to some extent to variable types and their representation. Yeah. I will talk very soon about this. So just wait a second. Yeah. So some of you know this concept, some not. Yeah. I will try to explain it in a second. Yeah. So, but it has to do with those double precision floating point numbers and other stuff. Yeah. So first of all, variables have types. Yeah. Especially if you work with some lower level languages, it's obvious. But here it's also, for example, here it's clear that it shows it's class double, yeah, and it makes, and everybody knows that it makes a difference if you write 2 or when you write something like that, yeah. So those are two different variable types, yeah. Of course, the first one is double, yeah, with the value 2. And the second one is string. Yeah. But there are many types of variables to use to represent the numbers itself. Yeah, like we can have integer representation. Yeah, with different length, and we have here just default for our engineering approach and for Matlab, double precision floating point numbers. Yeah. Double precision came from the history. Yeah. I think that it uses, do you remember how many bits or bytes it's used for double precision representation? It's 8 bytes. It's written here. Right? For double, you use 8 bytes. So for single, you use 4 bytes. So it means, how many like kind of memory you use to store the number. Then it's also representation. But what is important here is this memory is limited. Yeah. So you have only certain numbers, certain amount of those zeros and ones to store your number. Yeah. So, and here is the difference. Yeah. If you try to store pi in single precision, you can get only, it of course depends of what is your goal. Yeah. Typically for graphics, they use single precision for everything and nobody bothers and nobody complains about the games or something like that. Yeah. By the way, they use single because single are twice as fast typically as double because they are shorter. So it means that if you have 100 numbers, yeah, you can multiply them at once. Yeah. So simply multiplying 100 single precision numbers by 100 single precision numbers is twice as fast as multiplying double precision numbers. So for some extreme cases like graphics, it's very important, especially on GPU.
And the numbers are double the same as in C++ in Matlab, or is double precision not double?
I think that in C++, double precision is called float. And there is also some single precision that is called maybe single. But I think that also, yeah, okay. It was, yeah, now we have quite, big computers, a lot of memory. So, it's concerned only for those critical cases, yeah. But I think that the kind of default double precision number in C++ also uses 8 bytes. There are, of course, also longer precision types, yeah, like double the size or quadruple the size, but we are not going there. Okay, there are many, but yeah, so what is important? So first of all, for single precision, double precision, we can store those numbers in this case, but you can see that at the very end of the representation, you get those errors. Yeah, because you cannot store most of the numbers precisely. So what this computer system does, they are trying to store the number that you want to get in the closest way possible. Understood? Yeah. By the way, so yeah. So this is the reason that this is not precisely 0.2, but is the closest to 0.2 that we can get on the computer using double precision numbers. Is it clear? Yeah. If we change any bit, because byte is 8 bits, so 8 bytes is 64 bits. Yeah. If we change any bit, yeah, then we'll get further from it. Okay. Okay, so we already know this. We'll get back. I mean, we'll get back a little to those numbers because this also affects how we compare numbers, and comparing numbers is important for test. Variable names. Yeah, do you know how to name variables in Matlab? Because it's different than in Python. Because the variables that are allowed in Python are not allowed in Matlab, especially the one that starts with underscore. Yeah. So, but it's written here simply that names of variables should be descriptive. So this is just rule of thumb, yeah. That, and another rule of thumb is about the scope, yeah. So if you use the variable that you use in the whole program, it should be as long as possible. When you should use it locally, you can be shorter, yeah. So using the names like that one or A or T12, typically it's not advisable, yeah. Or just use it in very short context, yeah, that you don't have to figure out after, a few pages of the code what A was. Names, you can use letters, underscores, and numbers, yeah, so this is pretty typical. But name must begin with a letter, yeah. So in Matlab, and of course, all those remarks are typical for Matlab because in another programming languages, you have different rules for what is allowed as a variable. Yeah. So, for example, SX or underscore A are invalid in Matlab. Yeah, because like this statement would be valid in Python. Yeah, because you can write in Python that underscore is equal to 1 because underscore is valid name for variable. Yeah, but of course it's invalid in Matlab because you have to start with some with letter. Yeah, and the Matlab differs upper and lower case letters because it's also not the case because for the languages like for example Fortran. Small a and capital A are the same variable. Yeah. Here in Matlab are different. Some names are reserved, like for, while, if, else, and global function, because they are keywords and you cannot use them. So you cannot write 4 equal to 5. Or let's see, maybe you can. No, we cannot. Yeah. Because 4 is, it even okay, it doesn't even show you the reason why, yeah. So it shows some strange error, but 4 is a keyword for making loops, so we cannot use it as variable. There are languages that allow you to do this. Yeah, I don't remember Python, but for example, in Lisp, I think that you can change the name of everything. Yeah, maybe it doesn't even have loops. And it's better not to create variables with the name of I and J, for example, yeah, because I and J are the favorite names for making the indices for looping, yeah. But when you define them, that you lose the definition of the complex numbers stop becoming valid, yeah. So if you write I equal to 5, why not, yeah. But then if you write that x is equal to plus 4i, okay, it works. But I think that part doesn't work. Yeah, yeah. So so why this works, this doesn't work? Yeah, and if you have clear workspace, and you write that one and this one, it gives you the same output. Yeah. So then again, programming comes sometimes with some tricky questions, yeah, and this kind of the quirks of the language, while those small details matters, are sometimes the reason why you spend so many hours on debugging and not being able to find the error in the code that looks perfectly fine, yeah. But okay, yeah, so it's better to avoid especially A and J as variables in looping, which is odd, but okay. Formatting. Typically, last year I spent some time on it, but I think that now I will just present it to you, and you are clever guys. If you will need it, you will know how to use it. Are you aware of this function, like format? It's understandable how it works. So simply, this comes from old times, yeah, really old times. That's why it looks maybe a little like it looks, because it really comes from C. So like your grandparents maybe were using it in everyday practice. In Fortran, it was even awkwarder. But it works that way that you have a string, and then in the strings appears percentage sign. And here, because it's in the string, it means that it starts a format. Yeah. And then you have some format specification. Why? I don't know why it does. Yeah. Because I would like to find a laser pointer, but I cannot see it. But okay. Yeah. So it means that we will format it. After the dot, we'll put 3 numbers, and it will be shown as floating point number. Okay. D means, as written here, is integer. Yeah. So some decimal number. S means string. And then you have some format stuff. Yeah. Like percentage 5D, 5-character wide field. It means in typically the number after the percentage size means how large is the field. Yeah. So this means that we have scientific notation with 3 significant number, and 9 is the width of the field. Yeah. And most compact notation with 17 decimals. This is the meaning of that part. Yeah. And then we have some with this slash. I think it's backslash. It's slash or backslash. Do you remember? I always forget which is one. I think it's backslash. Yeah. I think slash is that one. Yeah. So after a backslash, you can put some special characters like tabulators and new lines. Yeah. Is it more or less clear what this will do? Yeah. There are also other, typically we use just this. We don't care so much, yeah. But just this gives us pretty nice control of how to format the numbers. Yeah, so if you want to make some kind of the table, yeah, it simply works nicely. Okay, random numbers. Do you know random numbers? What are random numbers? Do we have random numbers on computers? Yeah, not really. Okay, some of you knows. Yeah. So how they are called? Those numbers, how they are called? What rand function gives us? Yeah, but how are those numbers called? If they are not random? They're pseudo number, pseudo random. Yeah. Should be written here, of course. Okay, so just let's use standard help, yeah, because why you can use it, you know, this is more readable. Okay, not help but rand. So why computers don't have typically random numbers? No, because they are because execution on the standard processors is deterministic, and random means non-deterministic. So you get into how they are generated, pseudo-random numbers. Yeah? But again, the reason why we don't have real random numbers of standard processor is because, you know, again, they are deterministic. Yeah. So if you put 1 + 1, you will always get 2. If in working processor, yeah, you will never get 3 or something else. Yeah, because you can imagine processor that doesn't work that way. And I think that they are even working on this kind of processors. Yeah. Because, you know, because this requirement for being deterministic really hinder the efficiency of the processors. Yeah, if the processors wouldn't be deterministic, that could be much faster. But okay, uniformly distributed random numbers. Yeah, if you would get into it, you will start getting reading about the seeds and other stuff. Yeah. So because processors are deterministic, and sometimes we need the numbers that behave as random numbers, yeah, but we don't know that they are not random, yeah. There are special programs that are called random numbers generators that create pseudo numbers. pseudo random numbers, yeah, and typically they are initialized by seed, and if you initialize seed using time, typically you get them enough random that you don't bother. Does all this make sense or just cause some confusion? And having pseudo numbers is extremely useful for programming, yeah, because for sure, where is the seed? How it's called? How you generate seed? That was seed are not recommended. Yeah, so I think that range is the new way. Control random number generator. Yeah, so then you can provide seed here. Yeah, so just to show you how it works, yeah. So of course, if we have round in of 5, oh, let's see how round in works. Okay, so let's say that we have 10, 5, yeah. Okay, so round in times 5, 1. No, 1, 5. Because I want just to show it in the row, yeah. So here we have some random numbers integer, yeah? And of course, if we run it multiple times, then we have different numbers, yeah. But if we set a seed, yeah, for example, to 2, and then call it, we get those numbers, yeah. And then when I set a seed to 2 and call this function, I would get the same number. And for certain implementation of the random number generator, and at least you can be, they are for sure consistent within the given program version, because they will change for different MATLAB, then you will get different random number generators, yeah. But every time in this program, if I will run those two functions, one after another, I will always get the same output. Yeah. So of course, if I call it once again, then I will get different output. Yeah. But if I will call range 2 and then call those functions twice, as you can see, output is exactly the same. And it's not accident. It's always like that by design. So this means that those numbers behave kind of random, but are not really random. Yeah. If you want to have random numbers, you have to buy special module to your computer that will generate random numbers. But typically you don't need it. Okay. Clear? Yeah. Yeah, so then, okay. You have one generator, or I suppose, oh, okay, then it doesn't really matter if you have 1 or 5, yeah. Simply, you need, those are helper functions to get you depending on your needs, yeah. So if you need the numbers that have normal distribution, or you prefer the numbers that have uniform distribution, or you want just to integer number with uniform distribution or another distribution, depending on your needs, you either can use one output and then adjust it, transform it, because you can transform from one distribution to another and for real to integer, or MATLAB has multiple helping functions that provide you the input you need directly. So run the uniformly distributed pseudo-random integers. Clear? There will be pseudo-random, like all the numbers that you can get. There will be integers, so not real numbers, and there will be uniformly distributed. Yeah. So, and then random gives you uniformly distributed random numbers. By default, of course, they are pseudo-random, and numbers, it means double precision. Yeah. I think there is, for example, run n, yeah, rand n, for example, is another function that is very useful. Normally distributed pseudo-random numbers, yeah. So just with different distribution. Okay. Arrays. A collection of numbers is called array. Any questions to arrays?
Lucky draws are also everything.
Could you repeat?
Lucky draws.
Okay, I still cannot hear.
Lucky draw.
What? Lottery?
Yeah, lot.
You mean in real life, lottery? Okay, so you know, so that's why they often make it physical systems. Because with physical system, like throwing a dice, yeah, you already have get number outputs, yeah. But yeah, so the random numbers are very important, like for cryptography and maybe I'd say lotteries, yeah. So assuming that they want to make a fair lottery, they have to build particular systems with special care for this kind of issues to make sure that it's random. Yeah, so we cannot just write some program, simple program, and hope that lottery is totally random. No. Because there are two-way issues. Yeah? If you write it very simple, that, you know, this is one of the way that, for example, to hack the system. Yeah. If you use if you use in the place where you should random numbers, like in cryptography, the numbers that are not super random, yeah, but you can find some patterns, then you can, there are many cases when the people were hacking this kind of the systems, yeah. So this is one of the reasons why cryptography is hard, because you have to care about all those small details. Okay, I hope this answers somehow, yeah. So what is, okay, arrays, yeah.
At what point does actually allocating these zeros, like the array 4 actually makes sense? Like for 4 the array, I would say it's not too important, but at what size of an array should you allocate zeros beforehand?
Preferably always, if you remember about this, yeah, because it's that's true that it's here the efficiency will be measurable, yeah. By the way, when we should end at 11:30, I believe. Yeah, we have half an hour, yeah, because it's 11.
It says
It's until 12, so 3/4 less because we didn't make any break. I hope that you are still alive. Yeah. So yeah, half an hour and we'll end. Okay. So okay, so I will get to it in a second. Are there any questions about the arrays in Matlab? They are multidimensional. Yeah. By default, most of them has 2 dimensions, so like standard matrices. The characteristic of Matlab is that it uses parentheses to index the arrays, which is not obvious because many languages use square brackets. Yeah. It also uses 1 base indexes. Yeah. So the first element of the array is 1, 1. This is also not obvious because there's plenty of the languages that doesn't use indices, but it uses shifts. Yeah, so the first element is shift 0, 0, yeah, and languages like C or Python uses shifts instead of indices, but engineers are used to indices, so yeah, Matlab uses indices. Any questions to arrays? You know how it works, yeah. So this is the way they are indexes, yeah, because this is the vector, you can use 1 index. Can you use 1 index with arrays? Just single number with arrays? Okay, so what I mean that if you write something like x equal to that stuff, is it meaningful? Oh, No, you are mistaken. It's meaningful. So what will be x of 2? It uses format. Matlab uses Fortran order. So it uses this kind of the order. So here it works. So what will be x of 3? Yeah, exactly, -1. So now, arrays are 2D structures, but of course they have to be kept in the memory as a single structure because memory is linear. Yeah. So then for those that didn't get it, so of course we can store it that way. So 4, 5, -1, 2, or we can store it another way. 4, -1, 5, 2. Yeah. It depends. Most engineering software that I'm aware of uses this kind of ordering like Matlab. Notable exception is num array in Python that uses different ordering. Yeah, because even most libraries that I know in C or C++ use this kind of ordering by default. Yeah, but okay. Yeah, sometimes it's useful to know. Yeah. By the way, this is also a valid statement, and it will just show you all the numbers in the order they are stored in memory in the array. Yeah. But yeah, of course, if you want to be precise, you can write always 2, 1. Yeah. So second row, first column, and then you get without any doubt exactly what you want. Okay. Another quirk of the language. Questions? Works. Perfect. Yeah. Second row, first column. Use second row, rows goes first. Second row, first column. So it's fine. Those are two different things. Yeah. The one thing is how it's stored in the memory. It can be stored whatever. And another thing is about how to index it. So it's indexed row first, column next. Yeah. But it's stored in columns in the memory. Yeah. Okay, so about the memory allocation, yeah. So the issue with Matlab is that if you do not pre-allocate and you will change the size, it's totally valid. But it will allocate new memory, copy the memory, and delete the old memory. Okay, so if you write like here, age of 1 equal to 5, yeah, and then age of 2 equal to 7, what it does, it firstly, create new space, copy, and delete the old space. For the small matrix, it's not really the matter, yeah. But if you start writing longer programs and you use this kind of memory allocation all the time without pre-allocating, your program will be a few times slower. Yeah. Make sense? Yes. Of course. Okay. I wouldn't cut my hand on this statement because in most of the previous, because, again, language is changing. Yeah. So maybe they have changed their policy, but the latest policy I know, it was that they always did this. Yeah. So they never allocate because many languages okay. Yeah, so many modern approaches is that you allocate more memory than you need. So when you start inserting new data, you don't always create the new structure and copy because those creating new structures, copying, and so is very costly. Yeah? Especially allocating memory is very costly if you compare with some simple multiplications. Yeah. And as far as I know, Matlab until this always did this. Yeah, so new structure, copy old one. Yeah, and so if you allocate 100 numbers like that or 1000, it creates new structure 1000 times, copy memory 1000 times, and discard all memory 1000 times. Okay, and keyword known. Okay, because you don't know MATLAB, but yeah, it's written here. It gives you very last element of array, whatever the array size is. Yeah. So it's more or less when you have vectors, it's equivalent to that one. Yeah. Or maybe even for matrices. Slices. Concept of slices, I suppose it's known from in Python. You also have slices. So slicing 1 to 2, it means the first two elements. 1 to 2 to end every second element. No, because it's always like that you have start and stop. But if you have three numbers, it's start, stop, and then this is step. Okay. And in MATLAB, because it works on indices and not on the shifts, both ends are inclusive. From 1 to 2, it means 1, 2. Yeah. Okay. Clear? Plotting, we just discussed about the plotting, yeah. And then, do you know hold function for plotting? Yeah, you don't know, but typically when you plot, make plots, run plots several times, you create every time new plot. So when you want to make few plots and add the lines to the same plot, yeah, a same figure, yeah, you just run hold, yeah. So then after hold on, if you make some another plot, it will be added to this same figure, okay. And then you can write hold off to turn off this function, yeah. Or if you want to make two separate plots, you can call figure. Figure will open new figure, and then the new plot will by default go to the new figure. Clear? Known to most of you. If you want to change the styles, those are typically even here, yeah, in this ball plot, yeah. So let's get back with it. We have ty, so we have just two arguments, yeah, ty, yeah. You can always add third argument, which is a specifier of the style of the line, yeah. So by default, we have this blue line, yeah, blue continuous line. But for example, we can put here this style, line spec, it's called, yeah. And this means that we will put just marker points as a stars. So if you run this, because we have a lot of points, that's why we have a lot of those markers, yeah. So let's limit it to 11 to see it more clearly. Yeah, marker points, yeah. Here, for example, it means that we have dashed lines and all, yeah, and markers in the case of the circles, yeah. And it has different color because it's second. MATLAB has certain palette, yeah, so it shifts the color when you start adding lines. And then you can import the stuff, yeah. Save it as a file, yeah. So when you write reports for me at some point, yeah, with your homeworks, please do not make screenshots, yeah, because they are typically pretty ugly. However, now they start even looking better. But I don't know if this is the characteristic of this online version of the standard version, because it always have this gray border. I never understand why, yeah. But it's always better to save them, yeah. It provides better quality, yeah. For the word, use the meta. yeah, for the Word file. If you create report in the Word file, if you use it from in LaTeX, you can use PNG or EPS. Why? It's better to use meta PNG, not PNG, sorry, PDF or APS format than PNG format. Yeah, exactly. Vector quality versus raster quality. Yeah, it's plot. Yeah, when you insert vector plot, you can zoom it, whatever size. Yeah, but when you use raster, yeah, there are exceptions. When the plot is extremely complicated, it's better to use raster because then vector will open in edges, but we won't get to this case. Input text, I never use it. Yeah, but there is this kind of, at least I use it very, very rarely. But if you write sometimes wrong a program, you can always add user for the input and you just use input function. Yeah. And then, it can input something. Yeah. You can imagine that it can be useful. Yeah. Like, do you want to proceed? Yeah. Or, yeah, what is your age to calculate something else? Symbolic computations. This is pretty useful, at least I found it useful on many occasions. Are you aware of symbolic computations and do you know what does it mean and how it works? And what is the difference between standard calculus and symbolic calculus? Or standard, yeah. Let's see if I okay, so because I'm using this online, I haven't checked it. I have no idea if I have here symbolic toolbox, yeah. But x equal to 5, it is. It's variable and it has value 5 of double type, yeah. Y equal to 2, it's another variable. So of course, x times y, it's the result of this. And because we use numbers, it's a number, yeah. Good, I have symbolic toolbox here. Now, I can declare that x and y are not numbers of specific value, but are variables of specific type, yeah. Why it is useful? Because then I can use them for transformations, yeah. So if I write x times y, the result is expressions x times y. It's pretty obvious, yeah. But what, so why it is useful? First of all, you can believe me that this is useful, yeah. And there is many this kind of CAS softwares that use based on this, like Mathematica, Maple, there's Sash, I think there's Maxima, SymPy, and many others that works on this principle, yeah. So first of all, there is huge market of this kind of the software, and simply Matlab has one built in, yeah. And it's useful because of this kind of the computations, yeah. So then you can, for example, calculate, differentiate your equations, yeah. You can calculate the integral, symbolic integral. You can, and there are some helper functions like simplifications, there are solvers and others, yeah. And this is pretty useful if you want to just make some computations, calculations, or even develop some algorithm, yeah. One example is that what if we, for mechanical principle, how to write equation of motion for pendulum or double pendulum, yeah? Because for double pendulum, it stopped being trivial and it's already easy to make a mistake, yeah? So you can either, of course, write to it, or you can use known Lagrange principle, yeah? So we can use Lagrange equations, yeah? So you can write for double pendulum, for example, symbolically for your pendulums or masses, values that you have pendulum with M1 and then pendulum M2, L1, L2, yeah? Then you write kinetic and potential energy for those pendulums, and then use transformation to get equations of motion that you can export as a file. This is just one example, yeah, that I have used in the past. We'll use it we could use it, for example, then to use expressions for the constraints, especially if you need some Jacobian matrices, yeah, like solvers that solvers, for example, for nonlinear equations require often not only function but also Jacobian of the function. Yeah, so if you have a function, then you can calculate Jacobian based on those symbolic calculations. Yeah. Okay. Does it make sense? Does it sound like something that can be useful? Yeah. So, for example, here we can simply write that diff of x with ans with respect to x is, of course, here is trivial, yeah, but you can write and then you get y, yeah. And you can imagine that if those expressions gets longer and more complicated, you know, it became more and more tedious to make them, and it's easier to introduce error, yeah. So those symbolic computations sometimes are very, very useful and helpful, and we use them later. So it's good to be aware of them. Questions to them? Make sense how it works? Yeah. Of course, they have some limitations. Yeah. So if you have extremely complex expressions, but okay, yeah, we won't get there. Yeah, hopefully. Because it happens that it works 3 days and then produce nothing. But okay, yeah. And then it's frustrating. But well, this is the life. Okay, solve and others. So there is a bunch of the functions that works that way. Yeah? In most cases, you can use the same functions thanks to overloading for symbolic expressions like for other expressions. I hope that you know what does mean this overloading, like for sine here, yeah, that works properly, and so on and so on. Okay. And here is just for some basics, yeah. So create a 3D 3x3 matrix, clear why it works and how it works. Add 10 to each matrix element because, yeah, matrix element computations. Sign for transpose A, it's still transpose because with real numbers, it doesn't matter if we put this dot or not. Do you know this format long expression? Okay. This is format short, so it shows that 5.1 and by default with 4 numbers, yeah. But if you want to display it with different format, yeah. So for example, you can use format long, and then X is just more significant digits, yeah. There are also formats with scientific notation, yeah. So then you have the just scientific notation, and of course it matters, especially if you have -4, yeah. So then, of course, okay, it's really, yeah. So it seems that this by default it uses some of those shorthand notations, yeah, and then default is format short. That works that way, that we know. A times inverse of A. No. Do you know what does this mean? Does
Inverse.
yeah, this one will add.
The same as
It's not the same. It's totally different. Yeah. You mean, okay, so it depends. Okay, so we may talk about different. Okay, it depends on the context. Yeah. So from some perspective, you're right that this is the same. Because if we were to write both of those equations mathematically, we'll use the same expression. Yeah. I mean that it's different because it will use totally different mathematical procedure to calculate one or another. Yeah. And the second expression is much faster and it's much more accurate. And it doesn't calculate inverse of any matrix. And of course, it's identity only if A has full rank. Yeah, but this is about matrix calculus. Yeah, then we can stack the matrices together. And then we have some of those functions. Yeah, if you don't know Matlab, especially, it's good to know whose display works per variables. Yeah, so who shows what are variables in the workspace, whose shows the variables with some details. Yeah, then we have CLC, clears command windows. Yeah, so CLC, I have used it already many times, and when you typically use it also quite often. It just clears here the window. Yeah, and clear. What does clear do? Yeah, clears the workspace and maybe some other stuff. I don't. Yeah, we have to check the documentation again to be sure, but for sure it's clear workspace. Yeah. You go to help, yeah, but clear all clears a lot of stuff. It clears like handles, it clears caches, yeah. Yeah, so you use clear all only if you it clears global states, yeah. Yeah, so you don't use clear all until you have to, because it's much more costly, yeah. And for example, running the program again, it also clears the cache of just-in-time compiler. So it makes running the programs much more expensive. Yeah. TikTok, do you know TikTok? Yeah, pretty useful sometimes, yeah, for just timing the stuff quickly. It's not good for benchmarking, but if you have a long time of the code that you want to time just roughly, you can use TikTok. Tick starts because tick starts the timer, talk stops the timer. Yeah. What?
You can also use it in some things. Time.
Yeah, yeah, you can, but yeah. Yeah. By the way, if you want to time functions, I think that it's function can time it. Now they introduce it in one of the newest Matlab. Yeah, measure time required to run function. Yeah, so this is the proper way to do this, because then it makes proper benchmarking. Especially that, again, Matlab has now just-in-time compiler, so almost always the first run takes longer than all the other runs. And the same is for Python and many other interpreted languages with just-in-time compilers. Do you know what is just-in-time compiler?
Some things which can then constantly use again.
Yeah, exactly. Yeah. So if you write a function and you so in old Matlab, it was always like that interpreted always or interpreted everything. Yeah, but now it interprets it once and tries to just compile it. Yeah, it's not the full compilation. Yeah, but it just to find the patterns, just to make next runs faster. Yeah, it's very, very nice technique. While programming, you must accurate. Yeah, I hope we have seen it multiple times that just one symbol somewhere causes many issues. Like for example, this example, like in this multiplication of the square matrices. Yeah, and there are many other. Yeah. Time to time, it's good to use comments. Yeah. Fast code versus readable code. Yeah, you didn't get it, but there are ways to write fast code, and typically, we are not aiming of this. Matlab require a license. Fortunately, we have, but if you go to some corporate environment, it might make a difference. And know how to use documentation, Google, and no, okay. It requires updating. Yeah. Especially now the Google quality of the Google could be better. Yeah. know how to use documentation, Google, and LLMs, yeah, to help your programming. Any questions? Okay, good. So today we just scratched the surface of the Matlab. So now I assume that you are proficient Matlab programmers, yeah? So, oh no, we still have some other stuff, but so maybe we can cover it in 2 minutes, yeah? Conditionals. Do you know conditionals? If, else if, any doubts? You will learn how it works? Yes, okay, perfect. I'm referring to you because you know that you don't, I'm not super strong with MATLAB. So in MATLAB, it looks like that. If, else, and. Yeah, with no parentheses, nothing like that. You just put those comments, and then you have those standard Boolean operators and or. Typically, they are done with both when you put it to make a Boolean. Yeah. Because other than that, I think that you get those bitwise operators that we don't need it typically here. Yeah. Yeah. So here is the explanation. Boolean expressions. I hope you know. This is assign, no Boolean expression, another source of errors. Fortunately, I think MATLAB warns about it. If it's equal, non-equal, so this is this difference between the languages, but here is with this tilde sign, yeah? So this is important to note. Less than, less equal, and then stacking, combining it with logical operators. Make sense? Functions. So should we today discuss briefly about the functions, or you want to leave it for the next time? Okay. I'm not surprised because functions start to be a slightly larger topic, and functions can be nested. And MATLAB has some strange things about the functions because, as you know, the name of the function in MATLAB doesn't matter. What matters in MATLAB? You know that the name of the function doesn't matter in MATLAB. What? I don't understand. Okay, so because we really have to end, what matters in MATLAB is name of the file, because MATLAB, all other languages that I know, you put function and you write function, name, and something, yeah, arguments and whatever is the syntax, yeah, and then this name is really meaningful. But in MATLAB, it's not. Because in MATLAB, it matters in what is the name of the file that contains this function. You have only one accessible function. Yeah, so then name matters for the, but this is internal function. Yeah, for internal functions, that are two types of internal functions that can be nested or not nested. And then name matters, you're right. Yeah, so it also depends on the context. Yeah, but for global context of the MATLAB from the outside, what matters is the number of the file. The file. Yeah. Confused? Okay, we'll get to all this. Yeah. So really, so we'll start from here. So let's see what we have next. I hope that we have functions. A few things about functions. For loops, we'll go quickly through for loops. While loops. Okay, perfect. So after for loops, so functions, I think that will take the most of next classes to explain. Yeah, then we'll get to we'll quickly go to the loops with some nice hands-on, because then and then we'll get to first numerical method, which is numerical integration, and after that, yeah, let's see how it will go. But I think it's a nice point to stop. Okay. Any questions about anything? Any questions from online? Oh, there was even some chat. Where can I find the recording of this lecture? Okay, it will be available at Moodle. Yeah, I will upload those slides. Yeah, typically, 1 to 2 hours after each lecture, I upload the slides in PDF to the Moodle. Okay. Any other questions from anyone? Okay, so today was very basic about the MATLAB to be sure that everybody knows the MATLAB. But I hope that it won't deceive you because we will ramp up the difficulty level pretty quickly, yeah? Because now we talk about basics of the MATLAB. Next time we talk a little about those functions, for loops and others, which is nice. Functions already start to becoming difficult to some, yeah? Which is okay. Yeah, it requires some practice, and because it brings one of the most important abstraction levels to programming. Yeah, this is okay. But then we get directly to numerical methods, and we use some simple numerical methods like numerical integration and solving nonlinear equations. And then we'll jump from this to already writing the solver, yeah, which use dozens of functions, yeah, and we will start using some very abstract notations, and this will be also challenging. So, yeah, it also means that you should pay attention, especially to those homeworks that are submitted earlier, because typically they are much reasonably simpler than the next ones. Okay? Still no questions? If no, then thank you, and we will see you in 1 week. Okay, so thank you. Bye-bye.